Alright, so for this video we are going to learn about the sine and cosine functions. You're going to want a graphing calculator for this. More importantly, if you have your unit circle made that was done at the end of session 1, the one that went through all 4 quadrants and had all of the radians and all the degrees for all the 30, 60, 90 triangles and 45-degree triangles, this will make this worksheet go a lot faster. So let's talk about the sine and cosine functions. Now, first of all, sine is mapped to the y coordinate and cosine is mapped to the x coordinate. So I usually have students at this moment say sine and cosine, because the sine is bound to the y and the cosine is bound to the x. And that's built off of SOHCAHTOA, but since we're talking about a unit circle, since y is the opposite over hypotenuse according to SOHCAHTOA, the y would be the opposite side would be the y height. And since cosine on the unit circle is adjacent over hypotenuse and hypotenuse is 1, that's why it's bound to the x. Now it's important to note that we have a quadrant system here. Let's label our quadrants 1, and this quadrant over here, counterclockwise from the first quadrant, is quadrant 2. And by history, and procedure, we will always use Roman numerals for these quadrant numbers. This is Roman numeral 3 for the third quadrant, and here is quadrant number 4. With Roman numerals, 5 would be just a V, so IV would be the one before 5, so this is the fourth quadrant. So if we're looking at the first quadrant, our x value and y values are both positive. So our x is positive, so our cosines are positive here, and our sines are positive here. In the second quadrant, where our x is negative and y is positive, that would mean our cosines are negative, and our sines, I just put an x there. That's silly. What I wanted to do is just put the negative there. So our cosine is negative, and our sine is positive. Now in the third quadrant, we have negative x and negative y values, so not only is our cosine negative, but so is our sine. Now in the fourth quadrant, where we have positive x and negative y, this is where we'd have our positive cosine values and negative sine values. So what's kind of fun in the homework and also elsewhere in this book, they will give you some context clues about sine and cosine. Because notice it says here, what quadrant is point T located in if the sine of t is greater than 0 and the cosine of t is less than 0. Now the sine is your y value. So when is y positive? Well, y is positive in the first or the second quadrant. But that doesn't necessarily alone tell me where the point T is located. So now let's look at the cosine. What if the cosine is negative? So since the cosine is the x, when is the x negative? Well, that would be in the second or third quadrant. So if sine is positive first and second, and cosine is negative second and third, then our answer here is going to be the second quadrant. And the reason why is because if I put my dot somewhere over here in the second quadrant, you can see that the sine, which is my y value, is positive, and my cosine is negative. Now here, the quadrant, what quadrant is point T located if cosine T is greater than 0 and sine T is less than 0? I mean, I could look up here, but you can use process of elimination too. Cosine is positive, or the x is positive, in the first and the fourth quadrant. And sine, the y value, is negative in the third and the fourth quadrant. Well, you can see that this is true in the fourth quadrant and this is true in the fourth quadrant, so your answer is the fourth quadrant. And here you go. You can see that if I put my dot somewhere in the lower right corner, my cosine is going to be positive, that's my x value, and my sine is going to be negative, which is the y value. So that's kind of some fun sleuthing there. So now what we're going to do is use our unit circle from the session 1 video to find the exact values of the given trigonometric function. Now, the sine of pi over 6 is the same thing as the sine of 30 degrees. And at that value, from the unit circle you created, the y value is 1/2. The cosine of pi over 2 is the same thing as the cosine of 90 degrees. So what is the x value at 90 degrees? And that answer is 0, because it's straight up from the origin. The sine of 7 pi over 6 is also on your unit circle, and that's the same thing as the sine of 315 degrees. And that value, since it's in the 4th quadrant, is negative square root of 2 over 2, because that's my y value at that location. Finally, the cosine of 3 pi over 2 is the same thing as the cosine of 270 degrees, which is equal to 0, because the x value at 270 degrees is directly below the cosine value at 90 degrees, which is 0 again. The y value, or the sine at this location, would be negative 1. It's good to note that. Now we're going to talk a little bit about reference angles. And reference angles are useful because sometimes we spin a lot around a circle, but the reference angle is going to give us an equivalent measurement, and that's going to be useful when relating it to sine and cosine, especially back to the 1st quadrant. Because all the things we do can be kind of brought back to the 1st quadrant. So let's actually just look at a 1st quadrant angle. Now this line is called the terminal side. So this is an example of a terminal side that terminates in the 1st quadrant. Now, the measurement of that angle is going to be made by looking at the distance between the terminal side and the x-axis. So that means that if I make more of these angles, these will be equivalent. So these are equivalent angles here and here. You can see that I just did an example of something, then this is angle. I know this angle was created all the way this way, but the reference angle is created by going from the terminal side to the x-axis. So this is an example of a reference angle. And it would be compared to this angle over here, which would have the same distance of reference angle. So we're not actually caring about the distance going from here to here. What I just drew in red, I'm going to erase because it's just not that important. Because we can measure the distance from the terminal side to the x-axis, and we can see equivalencies, especially with the beginning of the next series of videos. We're going to use those reference angles to our benefit. Now, where would we go for the next problem? So here we are with a terminal side in the 3rd quadrant, and we would again go straight to the x-axis. We're going straight to the x-axis, and this would be obviously comparable to this right here and this right here if we needed to. So these 4 that I just drew are all comparable to this one that's drawn from here straight to the x-axis. I'm going to erase them, but this is the reason for doing these reference angles is because we can use this information. We can use that this distance here in the 4th quadrant would be the same as this one, this dotted line I'm making here in the 1st quadrant. And that's very useful if we want to find sine and cosine values. Now, the instructions in the actual homework is going to actually have you identify what quadrant you're in, and I've done so by showing you the 1st, 2nd, 3rd, and 4th quadrants. It will ask you for the size of the reference angle, so even if you traveled more than 180 degrees to get to this, let's say you traveled, I'm going to just show you with this thick pen mark here. You see how I traveled more than 180 degrees to get here? Perhaps I traveled, let's see here, how much? This looks like it's about a 60-degree angle, right? 60 degrees past the 180. So it looks like I went 240 degrees. Well, you would actually mark this as 60 degrees because it went 60 degrees to this x-axis. So this would be a 60-degree reference angle. So this measurement here, this 60 degrees, is the same as this. The whole reason for doing these reference angles will make a lot more sense when we start doing the work in the first video of section 6. And you kind of done this work already when creating the that full unit circle at the very end of session 1. You just, kind of were copying things with reflection. So that's where these reference angles come from. So to review, because we just kind of went over a whole lot of vocabulary and a whole lot of theory, from each quadrant, if you take the terminal side of an angle and drop it straight to the x-axis, you've created a reference angle. All right, so let's keep going. Okay, so here, I'm going to kind of put this into play here. For each reference angle, find the reference angle in radians. Okay, so we're going to do a little bit of conversion here. We can do so because we have our unit circle in front of us too. All of these are pretty friendly. Then it says find the quadrant of the terminal side and then use the sine and cosine for each angle. Okay, so it is cool if you use your unit 1 circle. So this is in the first quadrant. Okay, so the terminal side is in the first quadrant, the 45-degree angle. So we need to find the reference angle in radians. So the reference angle for this is going to be the sine of pi over 4. There's my radian angle measurement from the degree. And I need to find the sine and the cosine of that. And luckily we have our unit circle sheet in front of us. So this could give us square root of 2 over 2 for each of these. Alright, so now we go to problem number 8. Problem number 8 for pi over 3 is in the third quadrant. It's in the third quadrant. So this is 240 degrees. Now you can kind of see why I was maybe playing with this in the previous page. The reference angle to this would be 60 degrees. So the reference angle, now here the reference angle was 45 degrees because this is in the first quadrant, it's its easy measurement. Here the reference angle is 60 degrees. Or if we wanted to turn that into a radian, it would be pi over 3. So now that we have this, we have to find the sine and cosine of each angle. Now it said to find the sine and cosine of each angle, not the sine and cosine of each reference angle. So we're going to find the sine of 4 pi over 3 and the cosine of 4 pi over 3. And since we made this kind of a cheat sheet, if you want to think of it that way, back in the first unit, then we can get the values here at negative square root of 3 over 2 and this at negative 1/2 because they're both in the third quadrant. Alright, now so for the last two problems of these videos, we're going to look at 330 degrees. Now the reference angle is pretty easy for this one because 330 degrees is almost to the 360 degree part of the unit circle. So the reference angle is 30 degrees because it's the distance between the terminal side of that angle to the x-axis. Now what I'm going to do is take a look on my unit circle and see what the radian is at 330 degrees. Looks like it's 11 pi over 6. Okay, there's cosine 11 pi over 6. Alright, so if I look at that at 11 pi over 6, I got my beautiful cheat sheet in front of me right here, the beautiful worksheet that we created at the end of session 1. So that 11 pi over 6, that is going to give me a y value of negative 1/2 and an x value of square root of 3 over 2, because it's positive in the x value is positive in the fourth quadrant. Okay, now 5 pi over 6, it has already a radian, which is good. And let's check the reference angle. Reference, there we go. So, if I look at 5 pi over 6, hey, that's 150 degrees, which is only 30 degrees away from the x-axis. Now check this out here. So I got my sine of 5 pi over 6, right? And I got my cosine of 5 pi over 6. So now I take a look at my y value here. My y value is 1/2, and my x value is negative square root of 3 over 2. Now let's ignore the fact that this is negative, this is positive, and this is positive, this is negative. But you see the power of reference angles? You see how the 1/2s match? It's pretty sweet. And the square root of 3 over 2 matches. That's pretty awesome because these are reference angles. So apart from the negatives, these reference angles are exactly the same, which is really great because we used reference angles to create this chart by copying things we did in the first quadrant to the second quadrant, and then to the third, and then to the fourth. All right, thanks for watching part 1 of this video, and we're going to dive deeper into sine and cosine in the next video.